Okay, these are type of questions that is very, very, very fun and it's not difficult. But the thing is, people start to make mistake or because of time in exam, right? We stress. Then we can't do it properly. Okay, so let's do this together. It's very easy. With reference to the graph below, match the changes with the corresponding sections of the graph. So when you're given an equilibrium like this, with delta H, you definitely know you're going to play what? Delta H means you're going to play which factor? Temperature. When you have an equilibrium, you realize all of them are gases. You're going to play which factor? If they're all gases, pressure, the total pressure. Make sense? All right, high chance. So everything that we have discussed is all here. So I'm going to move this up and see what I can do with it. Okay. All in all, when you disturb the equilibrium will be disturbed and position equilibrium may shift and reach the new equilibrium. Everyone okay? Can So time 0, all the way to number 1. Then you do something, you disturb it, you will adjust itself based on the Shuttle's principle. Go to number 2 to reach the equilibrium, and number 2, or the equilibrium, and number 2, you do something again. Then what will happen? You achieve equilibrium again. The next one, number 3, you disturb again. Then what happens? So you keep disturbing it. You keep adjusting itself to the new equilibrium. Make sense? Okay. So one of the few things we can play with it. All right. It's all here. If you don't mind, I'm going to write it out so that I don't have to shift the screen. All right. 1, 2, 3, 4. The different sections is due to the A, B, C, D, E, F, G. So please allow me to copy down the A, B, C, D, E, F, G, which is here. All right. So here we go. Just a moment. What can I do? I use different color. Okay, here we go. Okay, now, which one you are easier to play? Which one you start to play first? Okay, I would like to place those whereby there's a sudden increase and decrease. See, don't highlight, I just highlight using a different color. I saw this using purple, right? You see those whereby there's a sudden this go up. Can see not? This going up. Later, then we match it to the actual color. I saw this, I think it's interesting. I saw this one go sudden going up also. We did this before, similar, but we didn't play in a graph. We did, but it's not so exotic. It's not difficult, right? Then where else? I saw there is a going down. This is all 3 going down. All right, and then is there anyone that go down? Have. There is one go down. So I'm going to target this 4 first, because to me, this 4 is easier to play with. Because there's a sudden increment or decrement. Make sense? All right. Okay, then I'm going to match the color inside here first. Ready? Now take a look at number 1. Number 1, right? Time 1. This one belongs to A to G. Which one? A, B, C, D, E, F, G. Which color? And therefore, which alphabet? This is that fast one. In exam, this come out in MCQ, A, B, C, D, 4 graph, right? I'll solve it within, I won't solve it in 5 seconds. I think 10 to 15 seconds we're going to finish up with. So you must be very comfortable and go very fast. This is what? This is, I think it's G, right? F. So it's F, G. It's F. Yeah, I use the alphabet and the color. This is F. I put like that, everyone okay? So fill into your box according. So I don't have to shift my graph. Why? Because there's an increase in your O2. That's it. And the rest never. And then they readjust themselves. All reactants will start to do what? As you can see, I repeat. All right. All reactants, they will always be used up in order to reach a new equilibrium, right? So they always go down and then they'll go down. All right. Later, I'm going to highlight this. All the products will always do what? The products always, all right, what happened? Get more and more, right? Make sense? The concentration will increase. Make sense? So I don't look at the turn out or turn down. The turn out or turn down is because of the reactants of product. Make sense, everyone? Cannot we own this, right? You go university, do chemistry or biochemistry, why not? The graph will come out again. It's the same thing. No difference. Even in tertiary education. All right, poly or university, same thing. All right, very easy. So it has nothing to do with the turn up or turn down. That is boring because that's how it turn anyway. All right, based on concentration time graph. Okay, so we have F ready. So I'm going to take a look at the other one, which is number 7, VII. That one, can someone tell me what alphabet is it? VII. That one is E, E, right? E. Looks good. Is it pink color? Because that graph that go down, All right, it has to do with water, which is what we mentioned here.
How do you even remove water in the first place?
Sorry,
How
how
to
to
remove
remove water
water?
vapor? They have all their ways to remove water vapor. Why not?
Oh, okay. So you see, like
Use
using
drying
drying
agent to
agent.
remove, right? Industrially, they have their own way.
So is this what you do, like drying agents, like
Maybe, don't know. All right,
Okay.
that's another level, right? All right, they have other ways, their own ways. So once again, this is E. I think that's firm. Once again, because it go down. Yes, everyone? And then they readjust itself. Done. So now we target the other two. The number 2 and number 4. Number 2, all of them go up. May I know number 2, what alphabet and therefore color we are looking for? We are looking at C. C is what color? Green. Let's see whether it is correct now, okay? C is increase in pressure. Now, why like that?
They're all gas, so if you increase pressure at constant temperature, you will decrease your volume via ideal
When
gas
you
law.
increase your, I will go bullet point, right? You increase pressure, what pressure? The total pressure. The whole flask. Am I okay? The P there stands for total pressure. Make sense? When you increase total pressure, if you don't mind, I go across this way. Am I okay? It also means it will increase the what? The partial pressure of all gases.
Right.
Make
So that
sense?
would
Everyone, the pressure will increase. And partial pressure, we say, is directly proportional to the concentration
yeah.
using ideal gas I've shown before, all right? Therefore, it also means increase in concentration of all the gases. And
So
yes,
is this
ladies and gentlemen,
assuming
they all go up.
wait, this is assuming temperature remain the same, right?
Yeah, they never say about temperature, though, it's assumed to be the same.
So yeah, decrease in volume.
Okay, if you are able to do number 2, which let me put the alphabet in, it should be C. You should be able to do number 4, IV. 4 refers to
Increase in volume, decrease in pressure.
increase in volume. Because increase in volume,
Directly means
RT bigger
less.
NRT, it means there's a decrease in your pressure. For the same reason, you reverse this one, you'll know what is happening. Make sense? All right, so consider done. Okay, everyone. All right, so this kind of equilibrium question on concentration time graph, I always look for that sudden up or down. Yes, very easy to target. And we finish it at first. All right, but again, some people will say, okay, I like to play temperature first. You carry on. 3 more, all right, and then we finish up. So if you're okay, I'll start to remove this and we finish the question in a while. Okay, here. Now, where you want to play first? We play with temperature. How about that? All right, so here we go. The Shuttle's principle, right? So I'm looking at A. Let's see A matches what? Or you would like to give me the answer. A belongs to who? You add heat. You think it's 3? We test it out. I'm not sure whether it's 3 or not. I used the wrong color here. 3, 3. Hey, just on my orange color, I forgot to match it. This number 4 is who? This D, Number 4 is D, 3, someone mentioned is plus heat. Let's see whether okay or not. Where's my red color? It's not that red, this color not that nice. All right, A. Okay, so here we go. Let's play. You say plus heat. Okay, so here we go. When I increase heat to the system, which also means increase the temperature. Heat means temperature, right? Le Chatelier's principle, once again, we've been doing this, right? It will decrease, the system would like to decrease the heat according to LCP. Make sense? Keep it very simple, right? To decrease heat, it means it favors endo or exo. Endo, right? We've been doing this for 2-3 weeks, right? So it favors the endo. Xavier, forgot to let you know you're new today. All the sessions are recorded now. It will be transcribed to YouTube video. By tomorrow, it should be up. You can access this all the way to your exam. It's okay? Anytime you want to. It's 24/7. Okay, don't know where to find, just check my admin. It's your job to support. All right. It favors endo reaction. Now, and then based on the delta H is given to us, forward is exo. Make sense? It's always written in the forward direction. So, therefore, reverse is endo. So, by increasing temperature, it will favors the backward reaction. Right? Make sense? If you favors a backward reaction, let's take a look at your reactants and product. What will happen? Your reactants, which is your NH3 and O2, their value will increase or decrease? Increase. And take a look, did you see them increasing in number 3? It did increase. Make sense? And this is how we explain, if they ask you to explain. Best they ask you to explain, because that's where the marks are. And anyway, we spend all the time doing it by explaining it, okay. All right, let me explain it. Done. And the product side, which is your NO and H2O, their concentration will decrease. And again, you can see very clearly here. Okay, so the rate is firm. I think we can go and take a look at B already, which is remove heat. All right, remove heat energy means decrease heat temperature. So this is obviously V. Okay, should be V, right? Okay, so V I think is B. And we basically just reverse everything, right? So let me just do this, reverse this. Okay, in blue color, here we go. When I remove heat, it will decrease the temperature. The shuttlers say increase back the temperature. That means favors exo reaction. Data keep quiet for a while, right? And therefore it favors the exo, therefore the forward reaction. Okay, so forward reaction means I got more product. So my NO product and H2O increase, my reactants will decrease. Product increase, reactant decrease until you reach the next equilibrium. Okay? All right, 10 seconds for you to clean up. You're going to write a bit for yourself, which is just a repeat. It's a reverse of the earlier one. Okay?
Then by process of elimination, the VI should be G.
Yeah, you can do that, but I will explain it. Yeah, I'll explain it.
No, I think even if in terms of explanation, catalyst does nothing to any of the concentrations at all. It only just makes that portion between 6 and 7 shorter.
Shorter, but they never show it shorter, right? So
no, as in now it is shorter, but without 6, it would be a bit longer. It's just like it will be faster.
Alright, anyway, the graph did not draw to scale, so I cannot comment on it. Okay? All I can say is, last one, when you add a catalyst, what does a catalyst do? Just what we just mentioned, right? Catalyst does not shift the position of the equilibrium, right? So if you ask me to explain, I have to write something, right? So once again, you have 2 occurrences. First of all, it does not shift position equilibrium, right? Does not shift the POE. If it does not shift the POE, it's as good as saying no change to equilibrium composition, i.e. the concentration. All right, all the words must come together, right? No change in the composition, i.e. the concentration. Make sense, everyone? What it does is that it increases, right, the rate of getting the equilibrium. All right, so the equilibrium reach faster. That's it. All right, that's the job of a catalyst. All right, by increasing both the rate of the forward and backward reaction by the same extent. Okay, all right, almost done. If you'd like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you'd like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.